Okay, the first reaction we're going to do in this reaction in aqueous solutions, the metathesis reactions and Ionic equations, what we're going to do first is we're going to do the first reaction, number 1. It says copper sulfate with sodium carbonate. So I'm going to add enough onto this test tube. So I'm going to get a little bit of my solution. I'm going to add about a dropper full. Then I'll return it. I'm gonna get the sodium carbonate here. It's just gotta make sure to be careful not to touch the ends. You don't want to contaminate. Okay, so here we're gonna go. And then as you can see, I'm gonna mix. And it created a murky substance. Right? It was a clear substance, a clear solution. And so here we formed a murky, cloudy solution. Let's add a little bit more, see if it changes here. And let me go ahead and get it close to you so that you can see it. Created a murky substance, not at all anymore. Let's go ahead and continue. And so here, once we mix those two solutions, if nothing would have happened, right, we would have ended up with a clear solution. But as you can see, this murkiness does allow us to does tell us that there is something that is no longer soluble. We have two see-through solutions, and then all of a sudden we get a murky one. So just go ahead and determine your precipitate. Okay. The next reaction we're going to do is number 2. It says copper sulfate and barium chloride. Hopefully you can see it, right? Copper sulfate, barium chloride. We're going to do the same thing. We got our setup of our test tube. We're going to add about a dropper full. Okay. I'm going to go ahead and close our substance. Now we're going to get the barium chloride. Oh, come on. We're going to go ahead and add our barium chloride. And you notice some cloudiness again, right? I'm going to go ahead and remove our test tube, shake it a little bit. And we did get a murky substance. Sorry. There we go. And as you can see again, this is a reaction between copper sulfate and barium chloride. Our third reaction is going to be again copper sulfate. This time we're going to react it with sodium phosphate. Hopefully you can see it. Hopefully I'm not zoomed in too much. Again, we got our setup with our test tube clamp, and we are getting our test tube. That way I can go ahead and add freely and I don't have to squat down, and then I'll go ahead and show you, right? So we have a clear solution. We're gonna add a dropper full. And then here we get our sodium phosphate. And we're gonna go ahead and add a dropper full of this stuff. Okay. And as we add our solution, you can see we do end up with a precipitate as well. Okay, a little murky substance. Let me go ahead and zoom in. And as we zoom in, whoa, that's a little too much, right? So we end up with a murky substance. Sorry, I apologize for the extra zooming in. So here we have, again, the precipitate. Make sure to determine your precipitate. And that's it. Again, copper sulfate and sodium phosphate. The next reaction is going to be between, let me zoom it out, between I'm sorry, sodium carbonate. And so here, as you can see, we got sodium carbonate. We're gonna add some sulfuric acid. And so just make sure that you get your observations. We have the same setup. We have our test tube. We're gonna drop some sodium carbonate. And then we're gonna go ahead and add some sulfuric acid. And so here, I'm gonna add a few drops. If you notice, the first thing that starts happening is we start forming gases. We start seeing some bubbles. Let me go ahead and add some more. You do start forming some gas formation, some bubbles. As hopefully you can see, we do have some bubbles. Let me go ahead and take it off real quick. So I can zoom it in for you. As we go ahead and mix, you'll notice these bubbles are forming. And so here we are forming a gas in our reaction with sodium carbonate and sulfuric acid. Okay. Reaction 5. Reaction 5 is going to be sodium carbonate again. And so here we have some sodium carbonate. We have some hydrochloric acid. We're going to go ahead and do the same process. We got our setup. We're going to add a dropper full of our sodium carbonate. And here we have our hydrochloric acid. We're going to go ahead and add and then again, you see, notice, hopefully, get it quickly enough, you'll notice some gas formation. Hopefully I can close it, get it back up. And, whoops, sorry. You will notice some gas bubbles in there forming. You will form some bubbles in this situation again. Again, let me go ahead and remove this from the clamp. And as I shake it a little bit, hopefully we get some more bubbles. But it's such a small concentration of the salt that we don't get enough of a bubbles. But we got a few so that you can make your observations. So we are forming a gas in this one as well. Okay. Okay, in this reaction, we are going to have number 6. It's going to be between cadmium chloride and sodium sulfite. And so for this reaction, as you can see, we have our dropper full of CdCl2 and we have our other dropper of Na2S. And we're going to do the same process, have our test tube right there. Going to add a dropper full onto our test tube of cadmium chloride, and then now we're going to get the sodium sulfide one. We're going to add a dropper full as well. Ooh, and look at what we get. Beautiful, nice yellow precipitate. Nice little formation. And let me go ahead and get you a little closer to it. And there you go. Nice little beautiful formation of that nice yellow blobs of precipitate. All right. And so again, this is the reaction between cadmium chloride and sodium sulfite. The next reaction is between cadmium chloride and sodium hydroxide. And so here this is, I believe, reaction number 7, if I'm not mistaken. Yep. Reaction number 7. Let's go ahead and get some cadmium chloride. And then we're going to go ahead and add sodium hydroxide. And so here, as you can see, get a nice little precipitate. Come on now. Sorry. And so here, as you can see, a little jelliness, right? So a big, thick precipitate. Little pinkish globules, right? Very thick. It did, as you can see right there, hopefully. The precipitate is a rather thick, almost gelatin type. All right. Next reaction we're going to do is going to be between nickel chloride and silver nitrate. And so this will be reaction number 8. So here we have our nickel chloride. Here we have our silver nitrate. So we're going to go ahead and add our 2 solutions. It's not cooperating with me. Add a little bit more. Okay. Let's go ahead and add our silver nitrate. Now you got to be careful with the silver nitrate. The silver nitrate is a staining solution, and so sometimes if it gets on your skin, you might get a temporary tattoo. And so as you can see, as soon as I dropped it in, we get a nice little precipitate. And there is our precipitate from our 2 solutions. It looks somewhat greenish. I don't know if you can tell, but definitely a thick blob of our precipitate. Next reaction will take place between nickel chloride and sodium carbonate, reaction number 9. So we'll go ahead and do both here. Again, give me a little difficulty, so I'm gonna have to. Oh, 1 drop, atta baby. One more of these and it should be enough. Okay, so that's our nickel chloride. And let's go ahead and add our sodium carbonate. We'll add a few drops. And we get some cloudiness here, not as sexy as the previous one. But as you can see here, we do get some cloudiness. And hopefully you can see your precipitate. Whoops. And so this is a reaction between nickel chloride and sodium carbonate. Next reaction is going to be between hydrochloric acid, and we got our sodium hydroxide. And so remember that hydrochloric acid is an acid, and sodium hydroxide is a base. And so, see what we see here. Gonna add about 1 milliliter, give or take, hopefully. Shake it a little bit. Gonna go ahead and add our sodium hydroxide now. And here, as you can see, nothing really happens besides that hint of pink, and that hint of pink is just probably contaminated with a phenolphthalein, okay, that I just realized right now. And so, but if you notice, nothing really does happen, as you can see visually. But then what you need to do is understand that in an acid-base reaction, we are looking for neutralization, Okay, so let's go ahead and see if we add some acid here. That hint of pink goes away. And as you can see, as I'm adding a little bit of the acid again, we break that equilibrium, and as you can see, there is no more pink solution. But if I add the sodium hydroxide, you'll start adding some pink until it completely gets that phenolphthalein out. Okay, but if you can see, nothing really, as far as observation goes, we really can't see anything. But don't forget that when we react an acid and a base, you're going to end up with salt and water. Okay. And just so in case you don't believe me, there it is. The next reaction we're going to do is that of ammonium chloride and sodium hydroxide. And so we're going to go ahead and get that reaction done. So we got our test tube, ammonium chloride, dropper full. Now we're going to go with sodium hydroxide. And this one also has phenolphthalein in there. I love it. In any case, disregard the pink. I went to go get a different one, see if it actually worked. See, but if you can see, there is no precipitate. That little white stuff inside, that's the indicator. And some of these sometimes are laced with indicators so that we can see what can happen. But here in the solution, right here, remember that when you have you have ammonium, and here you have sodium. Both of them are soluble, no matter what. Okay, so when those ions switch, nothing, like I said, besides the pink that is telling us that the solutions are basic. Aside from that, nothing else. Okay, so just go ahead and disregard the pink. Like I said, phenolphthalein is a base indicator, and that's all we're really seeing right here as far as this goes. But nothing really happened, no precipitate. So again, go ahead and do your ion exchange, and you'll realize that there is no reaction. In our next reaction, here we're going to have a reaction of sodium acetate. So we'll get our test tube set up. Here we have sodium acetate, and then we're going to react it with hydrochloric acid. So let's go ahead and get some sodium acetate. Put in our dropper full, and then we'll go ahead and close it, and we're going to get some hydrochloric acid and put it into our sodium acetate. And as we add it, right, as you can see, hopefully, right, nothing really happens. Okay. So record your results, and then go ahead and determine theoretically if there was something supposed to happen. Reaction 13 is going to be between sodium sulfide, hopefully you can see it, and hydrochloric acid, hopefully you can see that. And we got our test tube set up. We're going to go ahead and add a dropper full of our sodium sulfide. Add some more. Okay, goes our sodium sulfide. Now we're going to go ahead and add our hydrochloric acid. And as we add it, we see nothing really. And as you can see, whoops, I had to shift forward. I can tell you that it smells weird. Let's go ahead. That's your reaction between hydrochloric acid and sodium sulfite. It does give me a little hint of smells kind of like rotten egg. But there you go. Hopefully I didn't fart, right? And then blame it on the sodium sulfite, right? But just so just record your observation. It got a little cloudy, but definitely I can tell you that there is an odor change, and I can assure you that I did not bust some gas. Okay. For the following reaction here, we're gonna have lead nitrate, which is reaction 14, with sodium sulfite. And I can tell you that it still smells like rotten egg. So we're gonna go ahead and add a dropper full of our our lead nitrate into our test tube. And then we're gonna go ahead and add also a dropper full of our sodium sulfide. And I'll just go ahead and add a few drops so that you can see the type of precipitate that was formed. And so here, as you can see, you do have a nice little precipitate. Not our usual precipitate that we normally have been seeing. But here you can see that there is like a black blob, right, that is formed. And your job is to determine what that black blob is, right? Beautiful and sexy. Look at that sexiness, right? And so that is the reaction between lead nitrate and sodium sulfide. Okay, your precipitate in this case will be black. Whew. Next reaction here, we're gonna have a reaction of lead nitrate. Hopefully you can see it. And then here we're gonna have sulfuric acid, okay? And then so I'm gonna go ahead and add a dropper full again of our lead nitrate to our setup. Remember, I've been using a different test tube, not the same test tube. Okay, so now I'm going to go ahead and add some sulfuric acid, and we're going to see some excitement, hopefully. And we do. I added 2 dropperfuls. We add another one. Okay, I added 2 more drops of the sulfuric acid. I thought I had heard some fizzing, but I didn't. We're gonna end up with a murky substance, very, very white. I'm gonna zoom it in for you all, maybe if it lets me. There you go. And so there you can see the contrast. You do see white substance, and a lot of it has fallen, very heavy, very dense. You notice some of that precipitate does fall to the bottom of the beaker, while the soluble substance is still at the top. Okay, something completely different than what we have been seeing, but it could be to the fact that lead is very dense. Okay, so there you go. That's the reaction between lead nitrate and sulfuric acid. Okay, we're coming to our last and final reaction. This reaction is going to be between potassium chloride, hopefully you can see it, and sodium nitrate. Okay, and so we're going to do the same process. We're going to add a dropper full of each into our test tube setup. This is reaction 16. Maybe if it lets me, right? So we've added the potassium chloride. Now we're going to add the sodium nitrate. Alright, as we added the dropper full of each, you notice that it still remains clear. Nothing occurred. I'll put my glove behind it so hopefully it gives you some contrast. But nothing actually occurred in this reaction as far as observation. Make sure that you match it with the theory and see if something was supposed to actually happen or not. Alright, and of course that is our last reaction. We are now going to do section B for this lab, so just make sure to denote that and just go ahead and cross out section B for this section. Alright, all we're interested is in the double exchange of our metathesis reaction. You'll have plenty of work, trust me, with just determining the molecular equation, complete ionic equation, and the net ionic equation.
Okay.